So SQL, this is a large, it means longest chapter in our syllabus, and this will take going to take maximum time, and this is maximally used for our experimentation also. So as we complete the at least partial part of this chapter, we will start with our experiments also. So here the query is on single relation. So during the definition of relational algebra, we have seen that relational algebra, this is a procedural query language which takes one or multiple relations as input and produces a single relation as an output. So SQL is derived from the relational algebra and also relational calculus languages. It means the same strategy is followed for the uh, SQL also. And that's why SQL also is capable of taking multiple relations as input and giving the single relation as output. So whenever we are talking only about the query, we are referring to a select query only, not insert, delete, update, etc. So here query refers to a reading query, that is a data reading query, that is a select query. So this is having the maximum variation in the all the queries. It means what your queries are there, create or DDL or DML queries. Select is having the maximum variation. So first let us see which are the single operations or unary operations onto our relation. So queries on a single relation refers that we are giving only single query as a part of the query, and queries on multiple relations where we are passing input as a multiple queries where we are performing some binary operations also on our relational languages. So let us see this. So the first so let me tell you one thing that let me tell you one thing that so today I am conducting lecture on the laptop, and that's why here I'm using PHP myadmin. So let me show you the complete window. So okay, whether this platform is visible to you. So okay, this is a PHP myadmin. So this uses MySQL into the background, or we can have MariaDB also. So both are open source and both accept the same commands. Actually, difference between MySQL and MariaDB is that MySQL runs on a fixed port number, that is 3306, and whenever we wanted to install some another software database, we can go for the MariaDB. So exactly same copy of the MySQL is there. So here this is a PHP myadmin. So this I have installed only for the performing web applications. So in the web applications, as MySQL is using the fixed port number 3306, I cannot install MySQL and PHP myadmin on the same port number. That's why I need to, it means forcefully uninstall the MySQL, and only the SQL which is required for the web application only that I have installed. Now here PHP myadmin, this is at the background makes use of the MySQL, and the same port number will be used by this. So for this purpose, I was requiring a XAMPP server. So you need not to install XAMPP server, etc. Only here you can see that here MySQL is there, and here the port number 3306 is there. As we know, there are 64k ports are available into the every machine. Almost whatever our i3 from i3 or i1 processors are there, almost these are having 64k port numbers. It means these many applications we can install, and few applications are there which uses a fixed port number, and so is the MySQL. And for this purpose, if this the application into my web server is using this port number, I cannot install another MySQL to access this port number, because this is a fixed port number. We cannot allow two applications to use the same. Yes, both applications are same, but background is different. That's why I have uninstalled that. So simply, you do not get panic that each time I'm using the separate background. Last time I used MySQL, the command line client. Now in the last lecture I used Ubuntu, and now this PHP myadmin. But only thing you need to remember is that if you have installed MySQL server on your machine, Then whatever commands I am executing here, all these commands are clearly without any modifications are executable onto the MySQL also. So here we need not to go for show tables etc, show databases etc. So this is somewhat user friendly view. GUI is there. So here at this side, the left side of the machine, here we can see the databases, and if I click on the particular database, we can see the tables within that database. So these are the tables. So right now I'm using the sample database. I'm using right now sample database, and within that there are two relations, department, instructor and practice. So department and instructor are part of our interest. So practice, this was created for some another purpose. So these are the two tables, and still if you feel that why should not we use the same background as that of the previous, yes we can use. So use a database name sample. So I hope this query is visible to you. Is this query visible to you? So okay, use sample, I written. Visible? Whether this query is visible? Now I think this is visible now. So here there are many options are there, browse, structure, etc. Right now I'm using the SQL line to view this. So here we can write down our queries. So use sample, and at the below here goes button is there. So once we click this, our query will start executing. So use sample, it means database has changed. Now again we can go for writing some another query. Right now consider, let us see, I wanted to see the structure of department relation. So then we can execute describe and department. So describe department. So let us see what is the structure of the department. So simply click go. So this will execute your describe, and this will show that there are department name, building and budget is there. So varchar 25, varchar 25, and here again this is a primary key, and this is a building and budget is there. So this is how we are using this platform. So don't get panic. We are writing the same queries, and simultaneously you can run your query, whatever queries I am running here, you can run on your MySQL command line client also, and let us see whether there is any difference or not. Okay, so there is no any difference. Logical, there is no difference. But the thing is that in case of web applications, as our more focus is on the web development, we need not to focus much more on the queries correcting etc, and that's why some alternatives are given. Just like if I wanted to perform insert into practice, it will give me the query. If I once click insert, so this will give me the skeleton, and within that directly I can write the value. Only that is the difference here. So right now for your benefit, for your simplicity, will not use any of the tools right now. So let us focus on our current presentation. So queries on a single relation. Queries on single relation, find the names of all instructors. So select is used for filtering the columns, and from is used for giving the or listing the relations. So here before starting with this, I wanted to give you the main execution of the SQL queries. So SQL queries is always having the three clauses: select, from and where. So out of this we can we already know that where clause is optional, it is not a compulsory clause, but select and from are compulsory. So here whenever a DML compiler accept this query given for the interpretation, so first out of these the first clause executed is always a from clause, because here this is giving the relation as an input to this clause. So here first a complete relation is taken. On this relation, whatever the condition we have passed, that predicate is applied. And after checking the predicate, consider relation is having some 10 rows are there. Out of 10 rows, if consider whatever condition I am giving or predicate I am passing, out of these only 5 tuples are satisfying this condition and 5 are not satisfying this condition. Then here, whatever these 5 tuples are there, these will be filtered out, and those which are satisfying this condition, those will be sent to the next clause. And here, whatever the relation, all the columns are there, consider there are 4 columns. So where clause also accepts the complete relation as input, applies the condition, and those tuples which are satisfying this condition along with all the columns will be given as input to the select clause. And out of that only 5 tuples, and consider we wanted to display only 2 columns, these 2 columns will be listed here. Okay, so the always execution of the SQL query starts with the from clause. After the from clause, where clause will execute, so this will apply the condition, and later on select clause will select those columns which are ready to display. So even though we are writing the query select from and where, the first clause get executed with always a from clause, and then where, and then at the last select will be get executed. Clear with this? Clear with this? No any doubt in this? So okay, let us go for the next. So this is a queries on single relation. So here always select clause will give us the duplicate rows also. If consider I'm asking for the name etc. If two instructors are having the same name, then it will list all the names without removing the duplicates. And if you wanted to eliminate the duplicates, we can use the distinct keyword. So distinct keyword is used in order to give distinct values each time. Next keywords to it means if we explicitly wanted to display all the duplicates, then we can use the all keyword also. And again we have seen that we can perform some mathematical operation also in the select clause, that id name. If you wanted to check if simply we wanted to check the raise in salary by 10%, we can check by multiplication with 1.1. so these points already we see into the last lecture. Now we are moving towards the next point, that is queries on multiple relations. So here there are very rare cases where we are using only single relation. Always we access data from the multiple tables. So these actually, whenever we are writing the examination, it means theory examination, always queries are complicated in terms of multiple relations. So the schema will be given of 3 to 4 tables, and query will be any statement will be given. And as we are separating data, the it means as per our convenience, that personal details separate, academic details separate, course details separately. It means it may be fact that we want data simultaneously from all the relations. So here there are maximum cases are there where we are using the multiple relations as input. Here the query is given is retrieve the names of all instructors along with their department names and department building name. So here names of all instructors. So first let us see what is the schema of the department and uh, department and instructor relation. So instructor department relation is having the schema as department name, next building, and budget is there. So these are the 3 columns available in department. And instructor relation is having the columns id name, department name, and last is salary. So here in the query we have been asked names of all the instructors which is available into the instructor relation, and also retrieve the names of all instructor along with their department names. Yes, department name is also available, and department building name. And we know that as per this structure, department building name is available into some another relation called department. So here it means that we are trying to access these two fields and one more field from the another relation. It means two participating relations are there. So in that case also, the execution of the query takes place in the same way. That is from, where, and select. So it doesn't matter how many queries how many relations we give as input to the from clause. From clause can take multiple relations as input. At least one is required. So let us see how this executes. So if considered to the from clause, if I am passing R1 as first relation and R2 as second relation, the from clause execution of this, it means that this will perform R1 Cartesian product with the R2. This is the very first operation done during the execution of the from clause. So if from clause is having multiple relations as input, it will first perform Cartesian product of these two. So now, do you think that this will resolve our problem? So for this, I will remove this. So right now we are moving towards the answer of this query. So we wanted to display instructor name. We wanted to display instructor name, department name, and building name. Okay, not any building name, the same department building name we wanted to display. So here the first relation we will take it as a department, and the second relation we will take it as a instructor. So now, what is mean by Cartesian product? Can anybody give the answer? What is mean by Cartesian product? Cartesian product, it means that every tuple of the department relation will get multiplied or will get added to the instructor relation. So here, this may be fact that department contains CSE, mechanical, and other department, and instructors. There are 5 instructors. 2 belongs to CSE, 2 belongs to mechanical, and fifth one belongs to ENTC. So, do you think that we should compare? That means the CSE department should get mapped with the every instructor. Mechanical department should get mapped with the every instructor. So, and then we can get the answer correctly. The thing is that right now I cannot execute the queries because even though I have created the tables here, I had not added any data into these relations. Select star from department. Let us see. Actually, I had not added any data to the department relation. So let us add this data. Insert into department values. So I want to make the first entry for the CSE from second floor and with budget this much. Okay, the first tuple and second tuple I wanted to make from the mechanical with third floor and with budget as consider 8 lakhs. Duplicate entry for the CSE. Yes, here is the value. Department name CSE, second floor, 78 lakh budget. ENTC, second floor, 78 lakh budget, and mechanical third floor 8 lakh budget. So these are the three tuples which I have added, and let us add few tuples to the instructor. Instructor, sorry, values. As I'm adding value to the every column, each time I won't repeat the column list. So first, instructor name is A, department name is CSC. Also, I applied the foreign key constraint, and salary consider 78,000. The first tuple. Next, second tuple consider 2 with name B, with department name mechanical, and let us take 67,000 as salary. Okay. C, ENTC. Done. Okay, don't get confused that why here where one is written. This is because one always stands for the true, and in this particular structure where clause is not optional, that's why one is always a part of this query. So here there are four tuples A, B, C, D, ID 1, 2, 3, 4, departments, and salaries. So these are the tuples. So right now what we are willing to do is we wanted to take instructor name, its own department, and building. So now we are willing to write the queries. So the from clause here performs Cartesian product of these two. So now let us see what is the result of Cartesian product without using a where clause. Right now we are keeping the where clause as optional. So let us see what is the result of this. Select star from instructor, and to this I will pass another name as department. Okay, so this will perform the Cartesian product of these two relations. Okay, instructor and department. So let us see what is the Cartesian product of these two. Check the manual. Hmm. So here every tuple. So here first input relation is a instructor query. So first tuple of the instructor query ID 1 name A, department name CSE, and 78,000. And there are three department values are there, CSE, NTC, and mechanical. So whatever first tuple is there of instructor will get mapped with the every other tuple. So do you think that this is the right answer? From this we can take only name of the instructor, department name, and building. That will give us the correct answer. Anyone? Correct reply. So total there are four tuples into the instructor relation and three tuples into a department relation. So 3 into 4, there are total 12 entries are there. So if consider I'm willing to give that current faculty A is there, whose department name is CSC and building name is second floor. Right now CSC and CEC is there. That's why I can surely say that this instructor is having the department onto the second floor. But what about this? A belong to CSC department and mechanical department and building name is there. So which department we should choose? Either this department or this department. So here, whenever we are going for the Cartesian product, this will give us the concatenation of the columns and multiplication of the rows. And that's why this cannot give us the desired result. So for this purpose, we are writing the queries like this. So here, only passing the instructor relation, that won't give us the correct answer. So here, whenever we are giving two relations as input, here we should pass the select clause that whatever the common columns are there, that should be matching. That instructors dot department name should be matching with the department name. And let us see what is the result now. Yes, right now we are having only four selections. A belongs to CSE department, and this the same CSE department will be there. And right now I would display wanted to second floor. So it means again this is giving me the correct result. Department A, no other department is getting mapped, and will along with the B also, C and D also. Now we can select A, either we can choose this department name or either we can choose this department. Both department names are valid, and we can go for selecting the building also. So am I moving too fast? Are you with me? Okay. So let us see. Right now, whatever query we have written just now, that is correct. But in the listing, in the select clause, we only wanted to display instructor name, department name, and building name. We are not willing to give the other details like whatever displayed getting here, that id name, etc. So here, even though we are performing instructor and department, these two relations as input, in the where clause we pass the condition that instructor dot department name should be matching with the department name. So this one is done. And in the select clause, we are not willing to give only these all the columns. Only we want instructor name. Okay. Then department name. And the last one is building. So okay, now my question raises. This department name is from the instructor relation or whether from the department relation, because there are two columns belonging to the both the relations, and that's why this query generates an ambiguity that department name we cannot choose from either of the relation. Okay, let us see what is the output of this query. Right now, if I'm giving the department name simply, it says that column department name in the field list is ambiguous. So my DML compiler doesn't take this department name randomly from any of the relation. That's why this will make, or this will force us to take department name from the either of the relation, that either we should take from the instructor or either we should take from the department. Right now we are giving the equivalence condition, so it doesn't matter whether we take from the instructor or whether we take from the department. In this case, taking the value from the both will generate the same output. So let us see the output of this. Yes, instructor A is having the department name CSC, which is located onto the second floor. Instructor B is having department name mechanical on the third floor. C ENTC second floor, and D CSC second floor. So this is how we are solving this query. So again, so this one is done. So let us see some another tricks. So here, whenever we are going to write this queries, always we feel that here instructor, then department, then into the where clause pass the condition. Here if I put the condition I wanted to display instructor names and building name, those instructor who are having the salary greater than 80,000. So this will generate, it means much more lengthier queries. So here let us write the condition: instructor dot department name equal to department dot department name, and we are willing to pass the query as salary should be greater than 80,000. Okay, this is how we are writing the query. And consider here we are willing to pass or willing to list only the all the fields of instructor or all the fields of department. Then again we need to list here name, id, etc. So if we are again choosing the instructor department name here, so this will it means unnecessarily table name. This instructor name is getting repeated here, 1, 2, 3, or if any other column is same, the same name will get repeated. And so because of this, writing the query becomes difficult. So here we can go for simple rename operation. Rename operation, it means that we will use some another character for representing the table name. Just like here as instructor is there, so I will use another variable I here. Okay, so instructor as I will use. So I, it means that I'm using wherever I'm writing the I, that it means it is a instructor. So let us make the corrections into our query. I dot department name equal to for the department name department also I will use some another character D. So, and because of the same, here also I will make the correction like this one, D dot department name, which shortens my query to maximum strength. And here instead of I dot instructor dot department name, again I will use I dot department name. So let us see whether this is giving the same output as the previous one, name, I dot department name, and building. Done. Yes, it is showing me name, department name, and building here. So salary is greater than 80,000. So there is only single faculty into the CSC who is having salary greater than 80,000. So this is how we are writing the queries. Clear with this? Clear with this? So this was the query which we have executed. So again, we know the asterisk sign, that is a star. Star is also used for multiple purpose. Just like if I'm writing the star here, it will select all the columns from the instructor. So similarly, if consider we are going for the Cartesian product, let us see. And again, I will pass the condition like I dot, sorry, instead of instructor, I will use this as a character I, as I, and department name as D. Now here, I dot department name equal to D dot department name, and salary. This time we will go for, okay, forget about the salary. Now consider within this Cartesian product, again I wanted to check I dot department name equal to department dot name. Building I wanted to display. Yes, that's right, that building I wanted to display. But along with the building, I wanted to list all the details of the instructor. My question says that इन्स्ट्रक्टरचे सगळे कॉलम मला इथे डिस्प्ले करायचे आणि बिल्डिंग पण डिस्प्ले करायचे. In that case, we can go for I. So instead of going for ID, name, then I dot department name, and then salary. So instead of listing all the attributes in this way, we can go for simple like I dot star and then building. So this means that I dot star, it means that I stands for the instructor, and star asterisk sign, it means that this is going to list all the columns into the instructor relation. So let us see what is the output of this. So right now my query is select I dot star building from instructor as I, department as D, and department name equal to d I dot department name equal to d dot department name. So let us see this output. So here ID, name, department name and salary. Each and everything got displayed. It means all the columns of instructor relation are displayed, as well as building is also getting displayed. Done. Again, if right now by default I have given ID in the sequence 1 2 3 4, if consider we wanted to display these values into the reverse order, then we can. So I will use the same query. So here I wanted to control the display of these fields. Then here we can use the order by clause and order by. Right now ID reverse ID field I wanted to display in reverse order. So for reverse order we can use the DESC, stands for the descending order. So let us see here. Now we can see the display 4321. Done. So okay students, done. Any problem in this? So this is how we are writing right now this queries. So actually problem is that today is Wednesday and I'm having current shortage problem. My laptop battery will last for hardly 10 minutes. So this doesn't mean that we are closing our lecture here. I will give homework to you, and within the next hour you can solve this query, and by today evening you mail me those queries. So whatever schema previously we have seen, it means course id, instructor, etc. So I'm listing you the few of the queries for which, let us see where is my schema. So okay, your task, today's homework is that you should create a department relation, you should create instructor and course, and each of the relation will have at least 10 rows. Okay, you should have at least 10 rows into the each of the relation. So already via the Google link I have shared my material with you. Still today also I will share my material with you. That is a folder I have created for your study material. And somebody asked me class notes also. So all have you received soft copy of the textbook? Soft copy of the textbook is available with you. Okay, within that, whatever instructor relation is there, whatever department relation is there, please generate those relations. Hardly it is job of 1 hour. Only 3 relations you must create: department, instructor, and course. That's it. And remaining regarding teachers, etc. As we go on conducting the lectures, I will give next statements to you. So all of you, please check. Do you have access to this folder DB? Right now, I will share the link with you. So this is the folder I've created for your study material. With the task is clear to you? So okay, we will stop here. So please